Good evening, everyone. Welcome to another episode of Xah Talk Show. We are going to code Wolfram Language doing geometry. We are going to code graphics programming, programming animation. Continue from yesterday. You are watching Xah Talk Show. This is my keyboard, Ultimate Hacking Keyboard, UHK80, that one. Okay, so search for YouTube. You will see my reviews on YouTube. And now let's go to the topics proper. We did this, so we're gonna start coding. If you are watching this here, say hi here. Love to see your comments. If you are watching offline, play at 1.5 speed. Okay, so Asteroid, that's what we did yesterday. So what I'm going to do is basically I'm just gonna code work on my website. So we're gonna code a lot Wolfram language, so you can see we did this one yesterday. So let me show you this one. So play it so you can see that generates Asteroid. Now can you loop? Yes, speed, do a loop, play it. So this thing is called trammel of Archimedes. Trammel of Archimedes, and it shows. Wait, why is it not working? Oh, the browser's stuck. It shows this bar moves about, and the envelope of the bar is the Archimedes. Okay, hold on a second. My browser froze. Okay. So anyway, so this is called trammel of Archimedes. So, and the trace of this bar, the shape is called asteroid, and that shape can be formed by rolling a circle around inside another 4 times smaller, or you can roll a circle inside another, but now this time the radius is 3/4 of the bigger one. Sorry, that was my alarm clock. I need to stop it. I set it every an hour or two, so I get up and walk to prevent asteroid. So anyway, back to asteroid. So asteroid is this curve. You can generate it in multiple ways. One way, the definitive way, is rolling a circle 4 times smaller inside another circle. Okay, so you get asteroid, and this trammel of Archimedes mechanism is another way to form the curve. Okay, so we coded this yesterday. Here is the Wolfram language code using Wolfram language, and what we're gonna do is we're gonna work on this code, maybe possibly improve it. Okay, so it's probably boring for you guys, whoever you are watching. It's it may be boring, for those of you high school students, young people, or programmers interested in mathematics, then you might find it not boring. Okay, for example, let's paste the code. So here we did this yesterday. So now shift enter, and it defined the curve. So now you can just call this function. We define this function, and now you just paste it and shift enter. That will generate a bunch of graphics showing all these frames. See, trammel of Archimedes, and all you have to do is now you say list animate. Okay, then it will generate an animation. See, fantastic. Now you can play it forward and backward loop. Cheers. So how do you do this? Easy. The key thing to generate this is that you want to generate a bunch of graphics, so you do a loop in a programming language, right? You do a loop. By the way, if you don't know already, watch my previous video. You can see where to download Wolfram Language. Just search for Xah Lee Wolfram, download Wolfram Language. You can download at wolfram.com/developer. Okay, that's their website. So you need to turn on JavaScript. You can download it. It's like 4 gigabytes or 5 gigabytes. It's huge. It's the most advanced programming language based on term rewriting system. Okay, a magnitude higher level beyond Haskell, Python, Julia, JavaScript, F#, or Camel, Rust. It's like a magnitude beyond, meaning that for one line of Wolfram language, it's gonna be 10 lines or 1,000 or even a million lines of Python. Okay, one line of Wolfram language is like 10 or 100 lines of Python, or even a million if you count about, if you do, solving equations, solving partial differential equations, those kind of things. Okay, so you can download it for free since like a few years ago, and you also want to, basically just read my page. I explain, all the details, technical difference, Wolfram script, Wolfram engine, Mathematica, Wolfram language, what's the difference between them. Okay, so you download them. Okay, so and the other thing you want to download is the Wolfram language kernel for Jupyter notebooks. So that allows you to have graphics, okay, display graphics. Otherwise, you use it inside a terminal, like Wolfram script. You run it in a terminal, like a shell, like a bash, or Python repo. So anyway, so you download it. Okay, so that's the introduction. But now let's go back to talking about this. So for example, one of the feature is graphical programming, graphics, interfaces. You can do graphics. You don't need to think about, what kind of graphics library I need. It's built in, it's integrated, the whole coherent Wolfram language. Okay, so how do you do this? You see, to generate this animation, all you need is all you need is the essence of this animation is that you need to draw several frames, okay, several drawings. For each one, you need to move a bar, this bar, fixed length, okay, such that for each one, you need to find basically the beginning and end position of the bar, okay, the two, you need to find the coordinates for the two end positions of the bar. And for next frame, you need to know where do they move to, how they move. Okay, that's all you need to know to generate this. That's the essence of this animation. Okay, once you know that, you can do this animation in any programming language. That's the essence. So our code is here. So first of all, we define this function that generates animation. So first of all, this is the inline documentation, and this line defines the option. So by default, you're gonna generate 41 frames by default. Otherwise, you can for example, let's copy that. So otherwise, it's, you can like you can say number of frames, let's say 5. Okay, it's very short. So all you get is actually, so this is a mistake. Actually, this is not a mistake. You see, 5 frames, the bar is here, then the bar is vertical, then the bar is on the left, then the bar is on the bottom, and the last one, the bar is on the right. So 5 like fits. Okay, so you can set the bars like number of frames, let's say 9, make it like less even. So okay, you got that. So you got 9 frames of animation. If you change it to, let's say 15, okay, let's see what you get. Okay, you started to get some more frames, you see. So you can say lots of frames. You can say 90 frames. Let's try 90. Then it's going to be very refined. You see, very refined, 90 images. Wow, you see. Now you can, of course, you can make an animation of that. Okay, then let's do it here. And all you have to do is you have to say list animate, which takes an argument that's a list of images, list of graphics. Then it will create animation. Okay, so do it. So now we have this more refined thing. Okay. Cheers. Now let's get into technical detail. You see, what I want to do is to optimize this code. So this code I wrote like 30 years ago, and I can actually, let's do this in Wolfram Language. So let's see, let's do it here. So go to Astroid, page, show. Okay, and you guys, you can search for Visual Dictionary of Spatial Plane Curves. You'll find my website, and there is Astroid. Then you can see what we are seeing here. Okay, so we are talking about this curve. So we want, first of all, what should show? There are several things I want to do. One of them is to optimize this code. Okay, optimize this, because this is written 30 years ago. It's very efficient, but however, because 30 years is a long time, there's a coding style changes, and there's also possibly some Wolfram language changes. For example, let me tell you guys, 30 years. So this is like 30 years life experience. So for example, you see this hue with an argument 0.75, that represent kind of blue color. Okay, that's kind of blue purple. So that's a rainbow color. But today you have a symbol that just represent blue. And do you have purple? So let's see, purple. Yes, you do. So you see, 30 years ago, you don't have the function blue, you don't have the function purple. Those are symbols that represent the color. But 30 years ago, you have this generic, more like general purpose representation of color, one of the model. Wolfram language also supports RGB color, like RGB color. So you can also do RGB color, and with 3 arguments, each one is going to be like red, blue, green. So you can say each one must be between 0 to 1, not 0 to 255. The idiotic from programmer idiots, like the Unix and C people, they are idiots because they think 255 is the binary, like they use the byte to represent the value. But in Wolfram language, it's a mathematical based language. So each of the RGB value is from 0 to 1, the ideal situation. Like 0 to 1 is an infinite number of items. Okay, so anyway, RGB 0.5, that would be gray. Okay, shift enter to run it, so you can see it's gray. So anyway, and Wolfram language also supports SY, CY, and CMYK, YK, that's cyan, and cyan, magenta, that's subtractive color modeling. Anyway, so Wolfram language supports quite a few color models. So let's see the documentation. So you can see hue. Okay, so you can see hue color model. By the way, color modeling is fairly complex, actually quite extremely complex. Okay, so you got hue, which is one of the color model, like more intuitive. Then you got the RGB color. So RGB color model, let's go there. RGB color model, this is more simplistic according to kind of like physics, addictive modeling, RGB color. Then you got CMYK. It stands for cyan, magenta, yellow, and what is K? Yellow and black. Okay, so this is kind of like subtractive modeling of color, which is suitable for printing, like inks. When you want to paint, or you kind of use this model. Okay, so color models are very complex, fairly complex. Okay, so anyway, so Wolfram language supports all these models. But what I'm saying is that 30 years ago, you have hue, RGB, and CMYK, but you don't have like one symbol to stand for a color. But now you do. They added that, for example, let's look at, they added like that like 10 or 20 years ago. So the function blue to represent the color blue is added in 2004, fairly early. So that's 20 years ago. They added the hue. So that's why my code, so this code could use some improvement. For example, you see, this is back then I memorized the hue values. So 0.3 is like greenish, okay? 0.3 is greenish. So can we do that? Yes. So 0.3 is greenish, and that is the brightness, and this is the saturation. So this would be green. There it is. You see, like kind of like perfect green, dark green. So today you can, today there is a word to represent that color. You can just say green. Okay, well, do you have dark green? Not necessarily. Okay, I don't think dark green is built in. So anyway, the Wolfram language started to support named colors, but not a lot. Like they support like 10 or so, like fundamental named colors. Okay. So anyway, so you got green. Coloring is interesting because I can show you CSS color. So that's my website. So that's on xahlee.info, xahlee.info. Okay, so in CSS, you got colors, you got color basics. So these are my tutorials about CSS. Okay, you got color syntax, you got okay, there's something going on there because the background color is not filled with that. Anyway, so you got color picker. Anyway, so about color. So okay, so let's update the code. So I need to update the code. Yeah, let's just do something. Okay, so close that. Asteroid. Okay, so asteroid. Okay, so go to it. Go to search for pre. Okay, so this is the asteroid. Let's see. So here's a code. Okay, there's a lot to code. Okay, so if we're gonna code this, I'm going to code this. It's gonna be very deep Wolfram language, esoteric technical details. Okay, because I can go over like overall what's going on. How do you do it? It's pretty simple. Okay, let me go over the code. So first of all, you got this online documentation, inline documentation. This is like the doc string. So when you have this, people can type, people can just type, for example, question mark, Astroid generate the function name, question mark, and it'll tell you the usage symbol. Okay. Close, don't save. Okay, that's this part, usage documentation. Okay. You should have it, if you define your own function. Then this section is defining a optional parameter for this function, Astroid generator. Okay, that's how you do it in Wolfram language. Okay, so you basically you just say options Astroid parameter equals to, then in our case it should be number of frames is a parameter you created. Okay, so it's your personal, like for this function, this is a parameter for this function, optional parameter. But you want this function to also be able to take any options of the graphics function. So if you guys don't know, you see Wolfram language has this graphics function, which is allows you to generate lots of graphic stuff. Okay, so and it has a lot of for example, let's look at the documentation. So you can generate triangles. Okay, so you can generate triangles, you can generate arrows, you can generate Bezier curve, spline curve, B-spline, or well, the fundamentals are circle, lines, field curve, disk, half line, half plane, line, and point, and parallelogram. So those are like in triangle and text. Okay, those are like, these are graphics primitives. Okay, and exactly, so for example, you can see a line here. So you can see this is a line. This represents a line. Line takes a two argument of 2 points, coordinates, beginning of the line and end of the line. So that's how you generate all these lines. And once you have, so line is a graphics primitive, then you need to wrap it inside a graphics. You see this, you see, this is how you generate graphics. This is one single frame. Graphics, then hue means a color. Then you do some computation, like you take some of the list, generate a line. Yeah, that's basically the line list. GP is a bunch of lines. Okay. Yeah, so that's, you see, that's lots of lines. So anyway, graphics is like a wrapper for all 2D, two-dimensional graphics, and it takes one, like it takes any number of graphics primitives such as lines, circles, polygon, point, or text, or more complicated things such as an image, a raster image, infinite lines, join curve, inset. I'm not sure what is inset. Represents an object inset in a graphics. Okay, so it kind of gets complicated. Okay, so anyway, so that's graph. So okay, so you see, so this option, you define the number of frames as an option for Astroid generator, the function, but you also allow it to take all options of graphics. You can see all these are options for graphics. They include things like background color, axis, whether to draw it or not. They include other things like frame ticks, like if you like do you want like ticks on the axis, like ticks, or do you want grid? Do you want to draw a grid in the background? Those are like options for the graphics. Okay, so can you see that? Okay, so what we are saying is that we want this function, our function, to take all these options, valid options for graphics, so that user can, for example, let's do it. Okay, so let's say another, let's say grid lines. I want to show grids. Okay, so grid, what is it? Search for grid lines. Okay, so you should search for grid lines. Oh, interesting. Cancel. Okay, so you want to say grid lines automatic. Okay, now not so many frames, let's say 20 frames, and let's say list Okay, Shift Enter. So now you see we have this animation, but now we got these grids in the back. Kind of interesting. Not really. So let's see the grid. Let's change the option grids to can you like do 0.2? Does that work actually? No. So the grid lines needs to be it needs to be okay. X grid and Y grid. They grid lines specified separately in each direction. Okay, but how do you specify them? Grid lines. Okay. Okay, so they need actually be x pi to 2 pi. Anyway, we're not gonna worry about this. So what I'm saying is that this this is how you define an option for a function. Okay, then the heart of the function is this part. Basically, this part. Now this is a bit large, so let me shrink it. Let's see. Can we like shrink a little bit? Okay, we can shrink. So I think that okay. So this is a function. This whole thing. Okay. Okay. So what we want to do? Shit. Does that make sense? Hello. Hello. Color serve. Okay. So we're gonna. We're gonna improve the code. Okay. Let's do that. So to code this actually is fairly esoteric, you know, because you got so okay, so basically you call module. Module is like declare a block, declare local variables. So these are local variables. This module thing is just like it's just like local variables for the function. Okay, that's how you define local variables for this function. Okay, then you number of frames. This is how you get the optional value number of frames, which is an integer. Okay. Okay, so number of frames is an integer. Then t min, t max, t step. That's okay. The you see the bottom line is that remember to create this animation. It's too many. Hold on a second. So let's delete that. Now the bottom line, remember to create this animation, all you want is to know the location of the two endpoints of the bar. Okay, that's like 2 points. You need to know the location of those 2 points. So those 2 points are created by this. Okay, you generate a line. GP means graphics primitive. So you generate a line, and the coordinates are cosine at a value and 0. So the y-axis is 0. So you can see the y-axis if you play it, you know, the y-axis is always 0. This blue, the beginning of the, you see, the purple dot, the y-axis is always 0. The x-axis moves about. So that's this line. That's that cosine something 0 that there. And the other endpoint, the other point of the line is the coordinate is just 0 and sine something. Okay, so the other coordinate is a green one. So you can look at the green dot. You see, it just moves ups and down. Okay, So meaning that the x-axis is always 0. The y-axis moves up and down, okay? So that creates a line. This is the essence. You see, this is a heart, okay? Now you are wondering, so what am I doing there? So you see, that's why I need to you see this, that's this line, okay? That's this line. And this line can also be written. I'm written in a Wolfram language shortcut way. So, but it's cryptic. The syntax is shorter, but for most people, you don't understand what is this ampersand, what is /@ what is what is this number pound sign. But if I write it in a way you can understand, that would be like this. Okay, so let me try to do that. Okay, so let me do that. Okay, so actually, okay, so this line is equivalent to this line. So basically what you do is you map, so you can see you map a function, and the function is this function, okay, function of line, and the input is the pound sign, that's a number sign, and you map that to this this value, t range list. And what's t range list? T range list is defined, it's a range of numbers, okay? So this one is equivalent to that, so we don't need that anymore. So okay, so that's basically, that's a bunch of lines list. That's a list of lines, okay? When you map a line function, this to a list of numbers, so you got list of lines. So that is the lines GP. And once you got that, essentially, effectively you got animation, okay? So you see, but each time you want to draw all the lines of the past frames. So you don't want to show all the lines in one shot, because if you show them all lines in one shot, what you gonna get is the last frame. So every frame is gonna look like the last frame because you got all the lines, right? So you don't want that. You want, so for each frame, you want to generate a graphics. So each frame you take just you take from the list of lines only t items of them, you see. So where does t came from? T came from what? You see, for each, you see here. So t goes from 1 to length of t range list. So basically, each time you just take t items from the list. Okay, do I make sense? Is that like interesting? Oh, Jesus. I don't think anyone is watching me. So God, so that means I just why don't I okay, so what do I do now? Oh God, this, I can just improve on the code for myself. So first, so did we finish explaining the code? I think almost, basically. So you got this function. So this function defines, basically you have a parameters. You have two parameters, okay? One of them is t range list. By default, it's 0 to 2 pi. That's what that means, okay? The other parameter is the opts, OPTS, and that is the options pattern, which means when whatever user typed, it will be available in the function body as as OPTS. Okay, so you can see the OPTS is used here. See, okay, so that is a lot of Wolfram language code. Okay, so you define the options, you define the parameters. The module is a list of local variables. So these are local variables. And then you got number of frames, which is an integer. Then you got tmin, tmax, tstep. That's for generating the line. Like you want a value to control the movement of the endpoints of the line. So that basically t-range list, it's a tmin is 0 usually, tmax is 2 pi, tstep is usually like 0.1. Okay, so you got a list of t-range list of numbers. Then you create a list of lines by mapping to the t-range. Then what you get is, then you have the static GP, static graphics primitive. GP is my convention for graphics primitive, which means this graphics will remain there always in every frame. So this means hue 0.75, that's a blue. So you want a line from -1, 0 to 1, 0. So -1. So basically this static graphics primitive means you always want to draw a line regardless frame. You want to draw the vertical line and horizontal line. Okay, you want them to be there always. That's what this static GP means. Okay, then the moving GP means moving graphics primitives. So here you have a thickness, you have hue 0, hue 0 is red, then you have a line there. That, okay, so this moving GP is this red bar. Okay, that's like constantly moving. Just this one. Okay, this red bar. So the moving GP, depending on, so it also so this is a function. This moving GP is a function. Then you map, you see here you map the moving GP, you apply it at the t-range list. Okay, yeah, so okay, so anyway, so then you got the last frame. What is the last frame GP? Last frame GP is not used actually. Yeah, so that's the case if people want only the last frame of the graphics. Then what you do is you use a table. Table basically just create a list. It's Python. It's like Python's list comprehension. Okay, so anyway, the first argument is the expression. The second argument is t from 1 to, by default it's 1, from 1 to length of t-range list. So, and this expression. Okay, so basically hue 0 is red, then take from the lines, show up to the current number of lines, then you pass the options for graphics here, then you add the option of, so you see this is one single expression. You see the table takes two arguments, the expression and the variable from what value to what value. Okay, so this expression returns the graphics, and what the graphics is several parts. First, the main part is just a list of lines, and the red line, the bar, okay, the moving bar. You see the list of lines in the past and this current red bar. You see, that's the past lines, and this part is the current red moving bar. Okay, their location. Then, so basically that is the graphics. All you show is the past bars, and you show the static graphics primitive, which is the horizontal line and vertical line. Then you show the current moving item, which is this red bar. See, then the rest of this graphics thing, you see, graphics takes two arguments. The first part is list of graphics there. The rest is like a bunch of options. For example, you filter rules is like you pass all the options fed to Astroid Generator to the graphics. You put them here. Then you say aspect ratio. Aspect ratio automatic means that you want this to be not distorted. Okay, like 1 unit in x-axis means exactly 1 unit in y-axis. They have the same length. Then axis true, that means you want to draw the axis x and y. And then ticks, that's the ticks you want to show -1, negative 0.5, positive 0.5. That's what those are. And plot range. Okay, plot range is how much you want to show graphic. So you see, at the end of this function, it just generates a table. Table is just a list of things, like Python's list comprehension. Just generate a list of things. What things? Graphics. Okay, this graphic thing by the variable t from 1 to this length of t range list. Okay. So is that clear? Does that explain this how this works? Yeah, okay. So it takes 20 minutes to explain that. Okay. But what I want to do is but for me, I want to basically rewrite this function. Okay, because okay, yeah, okay. Every time I started to do this, I run into issue because I need to rewrite this. That's a thing. That's why I'm starting this live stream. I need to rewrite this code because first of all, you don't want to use module because, well, you should. I mean, if you want it to be the fastest code, then you shouldn't use module. Module has got lots of problems. Okay, module basically it's a lexical scope. Okay, so this is about variable scope of the technical detail of Wolfram language. So in Wolfram language, module creates a lexical scope. However, there's a high price to pay because Wolfram language is a term rewriting system. So you can't easily create like lexical scope. So what Wolfram language actually do is that whenever you use module, it creates new unique symbol names for all the local variables. So it creates lots of new symbols, okay, internally. So and that's very costly, very slow. So you want to use block instead. So, for example, I would improve the code right away like that. Okay, that makes the code much faster already by few microseconds because today computer is very fast. Okay, so replace the module by block, but there's a lot more issues I need to look. I can change, but if I have to also explain them, then it take like each one of these, like almost every change I want to make, I have to explain it, and each one will take 10 minutes or 5 minutes. So it becomes impossible for me to actually do work on this code when I do live stream because I thought I'm just gonna do live stream while I code, but I can, but then you're just gonna watch me code, like no explanation, like you have no idea what's going on. Okay, so I do need to explain. Then but like almost each item, it will take like 5 to 10 minutes if I'm gonna explain. So what are some examples? Well, first of all is this block versus module. Okay. If you don't know, so you can look at my Wolfram Language tutorial, search for it, you'll find it. And you can go to, so you go to the Wolfram Language in depth, and then you go to basics, comments, and print, string, and number, and boolean, list, and you'll have variable section, global variable and local variable. So you go to the local variable section. So you can see here, there are 3 ways to define a local variable in Wolfram language, okay? One of them is block, one of them is using module, the other one is width, okay? Block and module, block is dynamic scope, module is lexical scope, while width is local constants, okay? Each one of them actually got problems, okay? So in general, each one of them got issues. So the module is like technically the best because it creates lexical scope. So it's that's what you want. Okay, so well, I don't have to. You see, the issue is that then I have to explain lexical scope. Do you guys know what it is? So it's like every time I need to make a change, I need to, it becomes 10 minutes explanation. So I can't really actually code this because nobody knows what I'm doing. So anyway, so there are 3 ways to create local variables. Okay, so but the problem with module is that it creates like internally unique symbols. Okay, and it's pretty costly. It's pretty slow. So in general, you don't want that. But if you use block, then it's lexical scope. I mean, if you use block, then it's dynamic scope. Dynamic scope got its own problems because you got the collision with you have the potential of possible variable collision with global variables. So if you do not ever define global variables, then you don't have a problem. Well, but the fact is that people do define global variables, especially in Wolfram language, because it's just convenient, like x equals to something, right? So you got an issue there, block variable using dynamic scope. Then the other option is use width, which actually is the best. It creates local constants. But the problem is that you cannot, the later variables does not know the value of previous variable. That means no variable chaining, so-called. It's known as variable chaining. So you can't, so later variables cannot depend on the value of previous defined local variables. So if you want to do that, then you need to nest width, then which becomes very ugly, like width, nested width, kind of ugly. Now in Wolfram language, about 2 years ago or a year ago, the new version, they fixed that. But they fixed that by requiring, but they fixed that in some way by requiring you to have subsequent these curly brackets within the nested within the width function. So they kind of fix it, but it's not ideal. So because then you have subsequent variables. So anyway, so what I'm saying here is that Wolfram language, you got these 3 ways to create local variables, and they are not ideal. Okay, So then what I'm saying here is that this code I like to modify, change, is using is so it's coded 30 years ago, but if I'm gonna any change I make, it'll take like 5 minutes or 10 minutes to explain. So that is the problem. So I can't really work on the code. You see what I'm saying? So we just took 5 minutes to explain the block, change why we should, why I want to change the module into block. Okay. Then there's quite a few. For example, in this part, you are assigning 3 variables by okay. Well, so you see, I need to explain this. This range thing came from the input. So this range list means let's see what can you do that. Let's do the green. Okay, where's this range list? Search for. Oh, it's not found. That's a mistake. Okay, we discovered a code mistake. Did we? Oh, wait, no, that's correct. So range, it requires the head to be a list. Yeah, so this is a pattern, it requires the head to be a list. So so if you don't give it, the default will be that list. So but the problem here is that you see if the list got 3 items, minimum, maximum, and the step, then you turn them into numerical values. That's what this capital N is. Then you assign them to these 3 variables. Okay. Now, if the range list is not 3 values, then what you do is, then you take the first element, you take the second element, then the step is the second element minus the first element. So where does this maps? Where do they came from? T min. Okay, so if there's not 3 elements, you define them that way. Okay, yeah, so the first part is gonna be just if it's 3 items, otherwise there are several issues with this code. Okay, the way I would like to write it today is there are several issues equals to the code. Okay, so okay. So the way I would write it is, okay, so this would be second 2, and this would be just let's use that syntax, first, second, and the range would be, the step would be if, okay, so if range equals to 3, then that, otherwise, okay, in fact, Okay, so if it has 3 elements, then the T step is just that, okay? So that is just last at T range. Otherwise you say it's T max. Oh, T max is defined here. So you see, tricky. So you see this code, I like to kind of improve it to be like that, because when you run this code, it depends on like sequential evaluation. Okay, you see this last item depends on Tmax and Tmin having already have a value. So wait, is that, yeah, so if something that do I make sense? Okay, so but if we write this way, Tmax Tmin, so Tmin Tmax, okay, then otherwise you don't need that. Okay, number of frames. Now, do we have number of frames? Yes. And also I like to change the variable names, like number of frames. You could, okay, so anyway, so yes, it makes sense. Okay, so are you a Wolfram language coder? Because most people wouldn't know what I'm doing. So that is kind of so anyway, Tmax, Tmin, and T-step in well, actually, then you do T range list. You see there is a lot. So where are they used? You see, they are not used much. So except here, so you don't, you may not, for example, this variable T minimum is maybe redundant because basically it's only used once here. And T max is also kind of redundant because it's used here, but one more time here. So you probably don't need it. And what about T step? Where is the T step used? T step is used only once, so you don't need a set up a constant for it. These are like trivial details, but if you are doing optimization, that's what you are looking for. So in effect, we don't need, we spend like 5 minutes doing these 3. Actually, we don't need any of them. Do you guys see what I'm saying? Because this T min would be just that, okay? T max would be just that, okay? And it occurs one more time. This occurs one more time, so okay, so we can kind of replace that. And T step only occur one time, so T step is actually T step is like you can delete the T step. T step is just that, okay? So now we can kind of actually delete that, and we don't need this anymore. And T min, T max, T step all delete. So our code becomes much simpler. And yeah, so anyway, so number of frames, I like to rename this variable. I don't like this. And also this syntax, I like to change to this syntax, okay? So this delete. So number of frames, I'm learning it. Okay, so you are learning Wolfram language. Fantastic. Okay, so number of frames is equals to that. Now, where is number of frames used? Like one time, okay? Number of frames is used one time here. So do you need it as a standalone variable? Not really, okay? So number of frames, okay, delete it. Delete it, number of frames, delete that. This is just here, that, okay? So you don't need this variable anymore, okay? The T-range list is this is range. Yeah, range. You need a range. Minimum, max, for minimum to maximum and steps. Okay, so that's the steps. Now wait. Okay, so actually it's using T-min and T-max there. Well, okay, so you need well, so T-max, this is T-min, and this is T-max, okay? T-max minus T-min. Actually, so, we are kind of, like right now I'm doing blind optimization. This is not brainless. Because, for example, this, this definition, you see, we are defining this function. So by this pattern, so wait. So what this means is that it tells Wolfram language, whenever you see this pattern starting with Astroid generator, then a square bracket, then something inside, two items, okay, one item and the other item, optional. So if the first item does not occur, automatically assume this list, okay? So basically here is a pattern, and this colon equal means set delayed, okay? Again, you can read my Wolfram language for programmers. You can go to it. You can see set delayed, okay? So that is about setting a variable. So you can see number, boolean, list, expression, atom, head, variable, okay? Conditional loop expression assignment. So we need something like pattern matching, function, loop iteration. So you need then data structure basics, okay? So common print string, number, boolean, list. So what you want to know is variables, local variables. Let's go there. Okay, so wait, we did that. Okay, global variables. That's what you want to go. So let's go to global variables. So set, so you have this commonly used set, something equals to something, like x equals to 3. Then you got set delayed, okay, here. You see, that's the set and set delayed. Okay, so here it's talking about set, then set delayed is here. So you got this colon equal. That means set the right-hand side to the left-hand side symbol or pattern, okay? Set the right-hand side to the left-hand side, but don't evaluate the right-hand side yet, okay? Evaluate it only when the left-hand side occurred, like matched, you see? So that's the difference between set and set delayed, you see? You see, one is just x equals to something, syntax. The full name is set function. The other one is set delayed, is x colon equals to something. Okay, their difference is one is set delayed. So what's the difference? Well, set will evaluate the right hand side right away. So the right hand side, x equals to something. The something can be an expression, can be x, can be y, or can be complicated expression. It will be evaluated. Then that value will be set to x, meaning that whenever Wolfram sees x, you'll replace it with that value. Okay, but the right hand side is evaluated. Now the set delayed using the colon equal is that the right hand side is not evaluated. It will evaluate the right hand side only when the left hand side actually occurs somewhere. So that's a difference. Okay. Now there are several things I'm talking about here. One is the difference between set and set delay. The other thing is about the short syntax. You see, like in Python, or JavaScript or other languages, we are familiar with x equals to something. But that in Wolfram language is actually the function set x, two arguments, set x and y. Okay. So anyway, that's a set and set delay. So as an application here, what we're doing is this: we are saying that whenever you see Astroid generators, something patterns there, then colon equal means set delayed. So when you are telling Wolfram language, whenever you see this, replace them by the right hand side. However, because it's colon equal means set delay, that means don't evaluate the right hand side right away. Okay, so that's what going on. Okay, so why am I talking about that? Because this pattern that we are talking about can be written in a different way. Okay, this pattern, let me try to, so we are rewriting this pattern. This pattern can be written such that you don't do that. Okay, well, so you can actually say t min here. Wait, can you t min t max so that way you will actually have the value t min and t max, and this optional. So I'm pretty sure you can do that. Okay, so if you do that, then you have the value of t min and t max. Like, and you don't need this complicated t range first part, t range second part. Okay, so but in order to do that, then you need to evaluate the whole thing as an experiment. So for example, paste that, separate it, and so now we have that. So now instead of saying t range, we can just say wait, so delete that. Okay, so now with that we got that. So we got does this actually work? Yes, I think I'm pretty sure. Okay, so copy that. So you don't need this t range. T range is just that, so it's simpler. And t range second part is t max. And then what about the t steps? That's the third one. Is there a way to like? Yeah, we can actually. I think I can, but there's more code. Anyway, so you can see that we improved this code pattern. Wait. You see, we improved this line by, wait. Okay, this is, here is the original, then new. Okay, original and new. The question is, does it work? Yeah, of course. So hold on a second. So we can also the t min. This is just t min. Okay, and this is just t max. So okay, so it's simpler, you see. Does it work? I think so. Yeah, those, you see, this colon something is a way to specify default argument. But actually, it's much more complicated because, okay, so let me go to it. So let me tell you. So we are doing pattern matching. So that's like how Wolfram language works. Pattern matching, okay? The foundational mechanism of how Wolfram language does evaluation. And so what we are doing is that we are talking about this default value. So how does it work? Like, what do you mean by default value? So default value basically is a from what we want to do. We think of it like normal programming point of view. We think of that as default value, right? Because this parameter, what we really want is that if there is no argument given, it's supposed to take two arguments separated by comma. If there's no argument, then assume the first argument is going to be 0 and 2 pi, okay? And the second argument, if none is given, assume it's just assume it's just doesn't assume anything, assume it's empty, okay? Anyway, so from a normal programmer point of view, what we want is default argument, okay? But from a Wolfram language technicality point of view, these are pattern matching, okay? So you are trying to match your pattern that start with Astroid Generator, the symbol, then followed by square bracket, then followed by something. So the tricky part is this here, something. So here it means, so what we want is a pattern such that it can match empty. So if it's empty, then it returns this 0 and 2 pi as a list. But if it's not empty, then it returns whatever the user input, and it must be a list. You see, so this is the pattern matching part. So that part, you go to this. So here on this page, you have introduction to pattern matching. What does it mean? So you got left hand side, right hand side. You see, in our code, the left hand side is this. You see, Astroid Generator bracket something. The right hand side is this whole block. You see, and we are using set delayed. You see, colon equal. You see, so explanation of the pattern matching. So from a programmer's point of view, we are just defining a function. That's all we want to do. We want to define this function, which draws animation, okay? But from a Wolfram language technicality, the technicality of the Wolfram language point of view, what you are doing, this is pattern matching. This is defining, what you are doing is defining a rule so that whenever this left-hand side, this pattern occur, Wolfram language will replace it by this right-hand side. You are defining a rule. The left-hand side is this pattern. The right-hand side is this code. And it's set delayed, meaning that, don't evaluate the right-hand side yet, only when the left-hand side match some code. So that's pattern matching. So you got local and versus global pattern matching. Okay, so basically set delayed is creating a global pattern matching rule, global transformation, that you are telling Wolfram language that whenever you see this thing on the left hand side, just replace it by the right hand side. Okay. So that's this part. Then so you have two ways to create the rules of pattern matching. One is Okay, so local and global. So you have two aspects. For global, you have set and set delayed. Okay, we talked about. But for local, you got rule and rule delayed. Okay, wait. Yeah. Okay, I'm not gonna explain that. But anyway, pattern matching. So what you want? So then what you want is the pattern matching syntax. So how is it possible to create a function with optional parameters? Well, in Wolfram language, you have to do pattern matching. So that's when this part, pattern matching syntax. So that's when this, for example, what does the under low line mean? What does the colon mean? That's the syntax of the patterns. Okay. So what we here, so we have syntax for any expression. We have syntax for blank. Blank means anything. So that's what the underscore is. Then you can match. Okay, so then you got named patterns. So yeah, then so you can name the pattern so that when it matches, when you want to do the replacement, you can refer to the pattern by name. So you got the so this is actually the most complicated part about Wolfram language, because Wolfram language do computation by this so-called term rewriting system, basically repeated pattern replacement. Okay, or also known as syntactic transformation. Or you can, if you came from Lisp, you can think of Wolfram language is macros. It's all about macros. Okay, the macros is far more complicated than Lisp macros. So Wolfram language is basically a language of macros. Okay, so you got repeated pattern you can have, or if you came from Perl or Python, you can think of this syntactic transformation or macro language or the pattern matching. You can think of it as a regular expression, but instead of working on strings, it works on the code, the symbols, the code itself. So the pattern matches all this code. Okay. So anyway, pattern. So what we have here. So for example, we are talking about like default values. So the first part is a parameter such that if none is given, then you should assume this default list of two values. So what exactly is that pattern? So the pattern for that is here. Okay, somewhere here, pattern negation, advanced patterns, pattern sequence, pattern related to functional optional arguments. Okay, longest and shortest, very complicated thing. That's like analogous to regular expression, like longest and shortest match. Literal patterns. So wait, where's the optional? Default values. Okay, that's what we are talking about. So that involves a colon. Except alternatives, condition, no. You're talking about pattern test, no. Pattern with a conditional test. That is, you give them a pattern, but you want it to match only if a function returns true on that pattern, you see. So that's what that is. So repeated, no. So so wait, you want condition, okay? What you want is a default value. So you want to match a blank, which means like no expression. So when you I think, wait, is that right? I think so. Okay. What? What? Okay, so that's called optional. So you see, so the full name for this optional pattern syntax is called optional. It's just a function, optional. So the shortcut syntax is something colon something. So on the left hand side is a pattern. The right hand side is the default value. Okay. So you can see our code. You see this T range list on the left hand side is a value. Okay. That's a, well, actually, hold on a second. I think my wife is back. I'm gonna have dinner. My wife is back, so actually I think I'm gonna go. Oh God, shit. The thing about live stream is that, so I want, what? So did I already explain enough yet? What I want to do is just improve the code. So normally, I would just work on the code, but to do live stream, you need to explain it, right? But otherwise, people are just gonna see you code like they don't know what's going on unless they are already kind of Wolfram programmers and fairly expert. So, but in order to, so I need to explain for everything I do. So, but every item will take like more than 5 minutes to explain. So I can't even, I didn't even start to. Well, we did start to rewrite some part of it, but anyway, so we were talking about this optional thing. So you see a pattern and colon and the default value on the right hand side. So here you see the left hand side is a pattern. That means T range is anything. It must begin with a word list. Okay, that's a named pattern. Okay. You see, we talked about named pattern before. Named pattern, we mentioned it before. So the left-hand side is a pattern, that pattern. The right-hand side is listing, a list, 0 and 2 pi. So the right-hand side means default. So this P, a pattern colon something can be rewritten if you want to by this optional, the full functional form, because that's what it means, optional parameter. So you see, Wolfram, one of the, I think, great syntactical feature of Wolfram language is that everything is represented by the full functional form. Okay, even more robust than Lisp. Okay, like everything is this full, function name, square brackets, then whatever. But then you have the syntactic shortcut. They are equivalent. Okay, because when Wolfram language evaluate anything, it changes this syntactic shortcut syntax to this full form. So you can write this way or that way, either way. Okay. So anyway, so this syntax is a pattern, which means the left hand side is a pattern, and if it does not occur, like if there's empty, there's nothing, then it will automatically match and it will become supplied by this default value. Okay. So that's so here I explain typical usage. Again, this is my Xah Wolfram language code. Okay. I mean, for a tutorial, just search for it, xahlee.info on my website. So fascinating. Okay, so why are we? So we were explaining about this search for option. We were explaining about this basically from a programmer's point of view. We are trying to define a function that takes a optional parameter with default values. But from a technical point of view of Wolfram language, this term rewriting system, what you are doing is you are creating a set delayed pattern, and the left hand side is Astroid generator something, and it involves two parts. The first part is this thing, something colon something, and which actually means this pattern, optional something. Okay, so when this pattern, so when Wolfram language sees like Asteroid generator, like for example, like here, it doesn't see any argument. So this P is empty. It matches because of this pattern. It match, but it will Wolfram language will give it the value of definition, the like default. Actually, I should rename this to be default value because it confuses with definition. Okay, so let's rename that. So let's go to. So do I make sense? Okay, so optional. Wait, search for optional. Do I make sense? Like, is my live stream that makes sense? So it's like esoteric. Okay, so anyway, so okay, so refresh. So you can see I big fan. Thank you. Hello, Gika Gupta. In the module, how are the final values of T-min, T-max, and T-step determined from the user input T-range list, especially when handling the optional T-step? I love Emacs. What's your setup? Okay, I think I'm gonna go. So we're not doing Emacs today. So in the module, how are the final values T-min, T-max determined from the user input? Well, in the code, before we modify the code, you see, we in the parameter we don't have Tmax, Tmin. Tmax, Tmin are local variables here and there. You see, and they are defined here in this line. So Tmin, Tmax, Tstep equals to, if the T range is 3 items, then just equals to the range. The first item is T-min, the second item is T-max, the third one is T-step. But if they are not 3 items, then the T-step would be T-max minus T-min divided by the number of frames. Okay. Okay, I gotta go. So I can't fruitfully work on my code. I gotta figure out something. Okay, so because we haven't tested this yet. Okay, actually we have not tested the code. So can we test it? Actually, I'm not sure it will work. Okay, Astroid Generator, let's say shift enter. It does work. Okay. So anyway, so yeah, so our code, we did some modification. It works. We changed the module to block. Fantastic. And we also eliminated the variables T-min, T-max. We made the code shorter. But there's a lot to do. So anyway, I hope that's some useful. Okay, bye guys. I gotta go.